Hi everyone, this is Professor Nancy Mahan. Today I'll be going over the topic of rationals. And if you haven't done so already, make sure you print out the lecture for chapter 7a in Canvas Zoom. And just note on Alex for Math 140 is chapter 7a, but for Math 130 it should be chapter 5a, I believe. So it's the same topic, just a different number based on the classes. And I'll be going over this worksheet today. There will be 19 topics that I'll be covering, and this is due on Thursday by midnight. So the first thing we want to go over is what is a rational? Well, a rational is basically a complicated looking fraction where the numerator and the denominator have polynomials on it. And luckily, we just learned about polynomials last week. So polynomials have letters such as variables in them, and they also have exponents, and they have adding, subtracting, and they have terms in them. So there's a numerator and a denominator, and it's basically just a complicated looking fraction. So let me go over some of the rules of fractions, or review some fraction rules, and they'll apply to rationals as well. So like I mentioned, rationals are fractions with polynomials in the numerator and denominator. And if you just want to see what it looks like, if you look at our worksheet, these are all rationals here. They are fractions with polynomials in the numerator and the denominator. So they're fractions not just with the number 1/2 or 3/4, but they actually have a lot more going on, a lot more interesting things going on with exponents and variables and adding, subtracting, etc. So since we're talking about fractions, then let's review some of the rules of fractions, because polynomials follow those rules as well. So one of the number one rules of fractions, is that what can you not have in the denominator? You cannot have a 0 in the denominator, right? So can never have a 0 in the denominator. So if you forget about that rule, if you did 5 over 0, if you put that in your calculator, you'll end up getting an error, right? Or some type of message that says that this doesn't work. So 5 divided by 0, we call this undefined. So we can never ever divide by 0. However, please note if you put 0 over 5, that's a-okay. That just equals to 0. So 0 over 5 is okay, but anything divided by 0 is not okay. So any number divided by 0 is going to be undefined. So that's the first rule of fractions that we want to look at. So because of that, and I'll go over other rules of fractions as we go along and talk about how it pertains to rationals. But right now, let's take a look at number 1 and 2. So number 1 here has 6x minus 1 over 2x plus 8. And the question that they're asking is, find all excluded values in the expression. That is, find all values of x for which the expression is undefined. So basically, find x's, find what numbers, find x's that make this rational undefined. So what x's are excluded from here? And we call this basically finding the domain, right? Is finding out which values are excluded or included. So here's a fraction. We know here's a rational. We know from the rules of fractions that you can never have a 0 in the denominator. So I'm just focused on the denominator when I'm trying to find out what the domain is, or when it's defined or undefined. So here, I know that the denominator can never equal to 0, right? You can't have it equal to 0, because if you do, you're going to get it undefined. So what values will make this equal to 0? Well, we solve it like we would a regular equation. We want to isolate our x. So I'm going to subtract 8 on both sides. So I end up getting 2x is equal to -8, right? Sorry, the sun isn't working very well with this board. And after that, I divide both sides by 2. I end up that x is equal to -4. So here, I realize that if I put a -4 in here, if you check this, if you put 2 times -4 plus 8, what are you going to get? -8 plus 8. And that equals to 0. So therefore, if you plug -4 in here, that's going to make this rational expression undefined. So when they ask you find x's that make this rational equation undefined, x equals to -4 is the number that's going to be the problem spot. So that being said, let me give you guys a chance to go ahead and work on number 2. And number 2, if you look at your worksheet, says w minus 9 over w squared plus 2w minus 8. So again, same type of question. Find x's that make this rational undefined. So where do you look at? The numerator or the denominator? You look at the denominator, right? So if you look at the denominator, those are my eyeballs. You find out when does this equal to 0. So when does this equal to 0? So when does this equal to 0? Well, how do you solve an equation that's a quadratic? Well, you're gonna have to use factoring. So go ahead and try that, and I'll get back to you after this. All right, so now that you've had a chance to take a look at it, what did you guys get as the answer? The answer is w is equal to -4 and 2. Okay, so check your work, and if you're not sure how you got that, let me explain. So what we're gonna do is, because it's a quadratic, the highest exponent is 2, I see it equals to 0, so since there's 3 terms, there's no GCF, so I'm gonna Xbox it. So I'm gonna zoom through Xboxing right now. If any of you guys are still struggling with Xbox, please make sure you go back to my previous videos on Xbox. Here, what 2 numbers give me 8? Well, 4 and 2. One of them is gonna be negative, I'm not sure which one yet. I exit, I get 2w and 4w. Can I add or subtract this to get me 2w? I sure can. I could do -2w plus 4w will give me 2w. My winner chicken dinner numbers, so I need a negative right there. And 4 times -2 is indeed -8. So when I box that, I get w minus 4 times, w plus 4 times w minus 2 is equal to 0. Sorry about the glare, guys. Okay, and then I'm going to have to use a zero product property where I set each factor equal to 0 and I solve for w. So I subtract 4 here, so I get w is equal to -4, and then I add 2 on both sides here, and I end up getting that w is equal to 2. So that's why -4 and 2 are the answers. And if you want to check your work, if you plug -4 in here, you can get a 0. If you plug 2 in here, you're going to get a 0. And we know that a fraction with a 0 in the denominator is undefined. All right, in the next question here, we're asked to evaluate rational functions. Well, this is kind of a little bit easier because it's nothing new from what you've done before. When it says to evaluate a function, basically it means just to plug the number, the input inside the function and then spit something out, right? So here, find h of 5. Remember, this does not mean multiplication, not multiplication. What it means is that this is a function where the input is 5. So if you remember what a function is, in our previous section, a function is a machine where if you put a number in, it spits something out, right? And whatever you put in, so here in this case, we put in the number 5. So we put in 5 into the flip machine, and the machine is called h, and it takes in that number 5. So it's written as h parentheses 5, meaning it's going to take in the 5 and eat it up and do something with it. Well, what is it going to do to it? It's going to do this to it. It's going to do the 5x over 3x minus 9, and then it's going to spit out an answer. So here, when I plug in 5 in here, so h of 5 then, when I plug in 5, I'm going to do 5 times 5 over 3 times 5 minus 9. Right? So go ahead and try that once you plug that all in. Okay, so I realized I just made a mistake. Sorry, I'm human. So it's actually 3x minus 19 based on your worksheet. So based on the worksheet, if you plug this in, go ahead and plug in the 5 in here and see what you get. All right, so the answer should be 25 over -4, and this is the work for it. Keep in mind, you can put the negative on the top or on the bottom or on the side. It doesn't matter where the negative goes. All right, so now let's get into more of the heart of rationals. So right now we're going to talk about how do you simplify rationals, and this is covering topics number 5 to 13 on your worksheet. So when we talk about simplifying rationals, let's first talk about how do you simplify fractions. So just a review of how we normally simplify fractions. If I had, for example, the number, say 4 over 16, right? And I say to simplify it, meaning to write it in its lowest terms. So we basically look at the top and the bottom, and we say, what do the top and the bottom have in common that it's divisible by? In other words, what factors does it have in common? So the number 4 here, the number 4, so what we normally do, is that we divide the top and the bottom, but what they both have in common, what factor they both have in common, they both have a 4 in common. So because they both have a 4 in common, we write this in simplest terms, which is 1/4, right? So let's make this a little bit harder. So what if I had something that said, so let's just make it look a little bit more complicated. What if I had 8 times 2 divided by 16 times 9, right? So these are what we call factors, because factors are things that are being multiplied with each other. 8 is a factor, 2 is a factor, 16 is a factor, and 9 is a factor. What we could do is we could just multiply it all out and then simplify it, but actually the better thing to do is to simplify it first. So I ask myself, well, what do the top and the bottom have in common? Well, I look at the factor 8 and the factor 16 here. 8 and 16 both have an 8 in common. So I'm going to divide the top by 8, right? If I divide the top by 8, I get a 1. If I divide the bottom by 8, I get a 2, right? And then what do you know? There's a 2 and a 2 here as well. So these are factors. And if I divide the top and the bottom by 2, that's their common factor, I'm going to get 1 and a 1. So as a result, the answer is going to be 1 times 1 on top is 1. Divided by 1 times 9 on the bottom is 9. Okay. So when we simplify fractions, sorry, my knees hurt right now. When we simplify fractions, one of the things that we want to do is to write it as factors. If you write it out as factors, things are being multiplied with each other, then you could cancel out or divide out common factors. So let me just give you one more example of this, just to really hone in the point. If I had a bunch of numbers, say 3 times 4 times 8 times 7, just making it up, divided by a bunch of other factors, say 4 times 9 times 8, right? So just a bunch of factors that are being multiplied with each other. What you can do then, instead of multiplying it all out and then just having to simplify really big numbers, instead of doing that, what you're going to do is you're going to divide out the common factors, or what you would say, cancel out common factors, right? So here's a 4 and a 4. They both have a 4 in common, so I divide it out, so I get a 1 and a 1 there. What else? The 8 and the 8 also cancels out, so you get a 1 and a 1. Anything else? Okay, there's a 3 and a 9. The 3 and the 9 have a 3 in common, so divide the top by 3, you get 1. Divide the 9 by 3, you get 3. So as a result, on top, if you multiply the top, you get 7 over 3, right? That's a lot more simpler to do than multiplying it all out and having to deal with really big numbers. So now let's take a look at how we apply this to simplifying rationals. All right, so here we have this ugly looking thing, but guess what? You have the tools to simplify it, even though it looks complicated. It's the same rules as we did with fractions. So here's a numerator and here's a denominator. So these are already factors. So it helps me to circle what the factors are, just for me to really see it. Here's a factor. So factors are things that are being multiplied with each other. Factors, factor, 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 factor. Right? Those are all factors. So I say, what factors in the numerator and denominator are common that I can cancel out? In other words, so I look at the 35 and the 20 first. So I'm going to look at the 35 and the 20 here. Say, okay, just look at numbers. How can I simplify this? What do they have in common? They have a 5 in common, right? So if I divide the top by 5 and the bottom by 5, I end up getting 7 over 4. Great. So this becomes a 7 on top, and the bottom becomes a 4. Now I look at this part here. I have 3u plus 7 to the third. I say, what factors does it have in common with the denominator? I see this here that looks something similar to that, 3u plus 7 to the fourth. right? So the hard way of doing this is you write 3u plus 7 3 times, right? You write it down 3 times, and 3u plus 7 to the 4th, meaning you write it out, you multiply it by itself 4 times. So this is very tedious, but I just want to show you, again, something called the quotient rule. So here you cancel common factors. These are common factors. If you divide it by 3u plus 7, they cancel out to become 1. These cancel out to become 1. These cancel out to become 1, right? Common factors. So you're left with 1 over 3u plus 7. Just one of them on the bottom, right? So this is very tedious to do, to write it all out. So I just want to remind you guys of the quotient rule. Thank God for the quotient rule. So the quotient rule says that if you have a to the m over a to the n, remember what do? You do the top exponent minus the bottom exponent. So here the bases are the same. So if I do 3 minus 4, so the top minus the bottom, I end up getting 3u plus 7, top minus bottom, 3 minus 4 is negative 1. And since it's a negative exponent, you bring this to the bottom of the fraction, which therefore becomes 1 over 3u plus 7. So this here becomes a 1, and this here just becomes a 3u plus 7 to the first power, right? And then last but not least, let's look at the u minus 5. Sorry, this is getting kind of messy. So when I look at the u minus 5 here, I see u minus 5 to the 5th over u minus 5, and it's just to the first power, right? So again, I'm not going to write it out like this, how I did before. I'm going to use the quotient rule to simplify this. 5 minus 1 will give me u minus 5 to the 4th power. So this here cancels out, so I end up getting u minus 5 to the 4th. Super messy, right? So what I'm going to do is I'm going to erase this just to make it look nice and neat. So I end up getting on top 7 times 1 times u minus 5 to the 4th. So I end up getting 7 times 1 is just 1 times u minus 5 to the 4th, right? In the denominator, I have, I think I accidentally erased this, but there's a 4 here. In the bottom, I have 4, and this one, right, I had a 3u plus 7 to the first power that I accidentally erased it, sorry. So on the bottom, I have 4 times 3u plus 7, and you don't have to write to the first power. So as you can see, something really ugly and complicated turned out really simple and pretty. And that's one of the goals of math, is you want to make complicated things simplified.